And this is a bit of a reminder from 380, but I wanted to talk about it a little more now that we're talking about the context of what does the compiler do, what do these pound includes mean. Let's take a look at forward declarations and how they improve our compile times and also how they get us out of circular dependencies. Here's your classic C++ code right here as we learned it in the first place. You have a class that includes another class as part of it. So because of that, the compiler will need the definition of what a graphics is. A graphics is defined in this other header file. So we're going to have to open that other header file, copy and paste that definition here first so that we know what a graphics is. Now in a forward declaration, the goal is to get this pound include out of game.h, to get it out of game.h and put it in game.cpp instead. How do we do that? Well, if we change it to a pointer, then the compiler does not need to know exactly what it is. It knows what a pointer is. A pointer is 8 bytes. So it doesn't matter what a graphics is. It's a pointer. You can see that that's a pointer. And so by making a pointer, we don't need to know that, and therefore we don't need the header file. We can just use this forward declaration to tell the compiler that's not an unknown type. That's a class of some kind. By the way, quick tangent, sometimes it's a struct, right? If it's a struct, you say struct. If it's a class, you say class. And if you say it's different, then you're going to get a warning, even though nobody really cares. Okay, so back to it. So this is the forward declaration as we learned it in 380. That's how you want to do. The downside is now you've got a pointer where you didn't used to have a pointer. You used to just have a data member. If you want to keep a data member, you have to include the other file. If you're okay with doing a pointer, then you can do the forward declaration. Now, do you have to do the forward declaration? Usually not, but the other thing it really saves you from is the problem that graphics class may have a reference back to game. If graphics references game and game references graphics, you've got a circular include. Somebody's going to need a forward declaration. One of those has to be a forward declaration, or you just cannot compile that. Yeah, sometimes it's just needed. But in general, it's just your choice. And you may choose, I don't want to have a pointer here. I want it to be a member. And so therefore, I'm going to do pound include. You might say, on the other hand, well, I don't care. I can just make it a pointer. And if I make it a pointer, I'm going to then definitely do the forward declare. And if we're doing forward declarations, that opens up the possibility of the interface implementation design pattern. What is that? It's basically to double down and really embrace the idea of this forward declaration, where I'm going to create a class that is by design just an interface for another class. It has public functions on it, but it doesn't implement any of them. The only thing the interface class is for is to call into some private interface in this thing called my implementation. So there's another class, which we have forward declared, that implements all the functions. Why do we do something like that? The reason we might want to do that is if I've changed how the implementation works. I edit this file. If I have to edit this file for some reason, this file does not need to be recompiled because it was a forward declaration. So anybody who uses my implementation, they will use it by way of my interface. They won't call my implementation directly. They'll call my interface. And my interface will not change, at least not as often. So because my interface has not changed, everybody who's using this class does not need to get recompiled whenever my implementation is changed. And that's just basically an example of trying to leverage the speed boost you get the compiling time speed boost that you get from forward declarations. You don't get any runtime speed boost from it. In fact, there may be a runtime cost of doing this, but the point is to improve the turnaround speed of compiling changes to your code. So the point of that is to reduce compile time. How does a forward declaration reduce compile time? Let's give an example. For example, let's say we have files A, B, C, and D. We're going to have CPP files and header files for both of those. And we're just going to say that D pound includes C, C pound includes B, B pound includes A, up the chain. Next, imagine that we touch file A.h. That means you make an edit to A.h and you hit save. When you hit save on A.h, that's going to mark the timestamp. It will update the timestamp of the A.h file, and the compiler will know that the A.h file is newer than the A.object code, meaning A.cpp must be recompiled. We have to regenerate A.obj because A.cpp is dependent on A.h. It pound includes it, right? A.cpp pound includes A.h. So A.cpp must be recompiled and generate new object code for that. However, what happens with these other CPP files? B.cpp pound includes B.h. And B.h pound includes A.h. So B must also be recompiled. Similarly, C includes C.h. C includes B, B includes A. Therefore, C is also dependent on A and must be recompiled. And then D, same situation. D includes D, goes C, B, A. A has changed, so D must be recompiled. So in the end, just by making one tiny edit to A.h, we had to recompile all four of the C++ functions. So if we instead apply a little bit of forward declaration, we just making the one change here. Let's say that maybe the B class needs access to A.h, but B.h can use a forward declaration for that. So B.h does not include A.h, but B.cpp does instead. We just move the header file from B.h into B.cpp. Now let's take a look. If we touch A.h, what is going to happen? Well, certainly A.cpp is dependent on there. So A.cpp must be recompiled. And B.cpp directly includes A.h, so it must also be recompiled. But take a look at C. C includes B.h, and B.h no longer includes A.h, so C does not need to be recompiled. And likewise, D does not need to be recompiled. So that's how we've boosted the speed of compiling by using forward declaration. Many files will not need to go through the compiling step or the pre-compiling step when we make a change to a header file now.